Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Muhammad Amir bin Zahran and today I will be presenting my proposal defense. This is the table of content for my presentation. This is my research title: Comparison between protective gears, conventional versus 3D printed shin guards for football on protection. Moving on to the background of study. To begin with, football is a high contact sport with frequent sprinting, tackling, jumping, and collisions with other players. Lower limb injuries are very common, especially around the tibia and surrounding soft tissues. According to B et al. 1995, shin guards are important protective equipment used to reduce impact force and injury risk. Although conventional shin guards are widely used, it also have its own limitations in customizations and designs. 3D printing offers new opportunities for customized, lightweight, and complex protective designs for shin guards. Let's continue on with the problem statement. Although conventional shin guards are widely used, it also have limitations in customizations and designs. Recent study shows that advanced materials, lattice structures, and multi-material systems show potential for better impact protection. However, most existing studies focus on materials or general protective equipment rather than football-specific shin guards. In addition, there are only limited studies that directly compare conventional shin guards and 3D printed shin guards. Therefore, this study investigates whether 3D printed shin guards can provide equivalent or superior protection. Purpose of study. Based on the identified research gap, the purpose of this study is to compare the protection performance of conventional shin guards and 3D printed shin guards for football using lab impact testing. This study is guided by three research questions. Question 1. What are the protection levels of conventional shin guards? Question 2. What are the protection level of 3D printed shin guards? Question 3. What are the differences between conventional and 3D printed shin guards? Corresponding to the research questions, this study has three research objectives. Number 1, to observe protection levels of conventional shin guards. Number 2, to observe protection levels of 3D printed shin guards. And number 3, to compare protection levels between both shin guards. This study proposes two hypotheses. The null hypothesis states that there is no significant difference between the protection levels of conventional shin guards and 3D printed shin guards. Meanwhile, the alternative hypothesis states that there is a significant difference between the protection levels of conventional shin guards and 3D printed shin guards. Significance of study. First, it contributes to the field of sports engineering. Second, it may assist manufacturers in developing more effective shin guards. Third, it expands the application of additive manufacturing. And finally, the finding may serve as a useful reference for future researchers. This slide presents both the limitations and limitations of the study. The limitations. The study is limited to comparing conventional football shin guards and 3D printed shin guards. The evaluation focuses on only two variables, namely impact force and energy absorption. On the other hand, there are several limitations. Since the testing is conducted under lab conditions, it may not fully represent actual football match situation. In addition, the study only evaluates a limited number of specimen designs and does not assess player comfort or long-term durability. There are several assumptions are made in the study. First, it is assumed that all testing machines are properly calibrated before each experiments are conducted. Second, the testing conditions remain consistent throughout all trials. Third, the measurements obtained from the testing machines are assumed to be accurate and reliable. And finally, it is assumed that all tested specimens represent their respective categories of conventional and 3D printed shin guards. Operational definitions. Conventional shin guard refers to a commercially available football shin guard. 3D printed shin guards refers to a shin guard produced using additive manufacturing technology. Protection refers to the ability of the shin guard to reduce impact during testing. Impact force is defined as the force transmitted during an impact event. Energy absorption refers to the amount of energy absorbed by the shin guard during the impact. Moving on to the literature review section. Football injuries and injury prevention. Football is a physically demanding sport, and previous studies have shown that lower limbs injuries are among the most common injuries experienced by football players. Therefore, injury prevention has become an important focus in sports science to improve player safety. Lower limb injuries in football. Robertson et al. 2022 reported that the tibia is one of the most vulnerable areas during football matches because it is frequently exposed to tackles. These injuries can affect a player's performance and require a long recovery period. Therefore, protecting the lower legs is essential to reduce injury risk. Protective equipment in football. Shin guards are widely used in football to protect the lower leg from injuries. According to B et al. 1995, shin guards are effective in reducing the force transmitted to the tibia, making them an important piece of protective equipment of football players. Additive manufacturing. In recent years, additive manufacturing or 3D printing technology has gained attention in sports equipment development. According to Nova and Nova 2021, 3D printing offers greater design flexibility, customizations, and the ability to produce lightweight protective equipment. These advantages make it a promising technology for football shin guard development. Materials used in 3D printed sports protection. In this study, PLA, PLA+, TPU, and PETG will be used. According to Putro et al. 2025, each material has different mechanical properties such as strength, flexibility, and impact resistance. Structural design. Structural design plays an important role in impact protection. According to Liu et al. 2026, advanced structures such as lattice designs and oscillatic designs can improve energy absorption while maintaining a lightweight structure. The literature suggests that better protection depends on the combination of suitable materials and effective structural designs. When these two elements work together, they can reduce impact force and improve energy absorption, resulting in better protection for football players. Research gap. Although many studies have investigated protective materials and 3D printing technology, several research gaps still exist. Most previous studies focus on materials or general protective equipment rather than football shin guards. In addition, only a few studies directly compare conventional shin guards with 3D printed shin guards. Therefore, this aims to fill gap by comparing their protection performance through lab impact testing. Research design. This study uses a quantitative approach with a causal comparative research design. This design is suitable because the study aims to compare the protection performance of two existing types of football shin guards without manipulating any variables. The independent variable is the type of shin guard, while the dependent variables are impact force and energy absorption. Population samples subject. Unlike most sports science studies that involve human participants, this study uses football shin guards as the research specimens. The specimens consist of one commercially available conventional football shin guards and two different designs of 3D printed football shin guards. Using a lab specimens allow accurate and consistent measurements without variations caused by human participants. These are the specimens that will be used throughout the study. Sampling technique. This study uses purposive sampling because the specimens must meet specific characteristics required for the research. The conventional shin guard must be commercially available, while the 3D printed shin guard must be produced according to the selected designs and material specifications. This sampling technique ensures that all specimens are suitable for comparison. Inclusion and exclusion criteria. Before testing, all specimens are screened based on the inclusion and exclusion criteria. Inclusion. Only commercially available conventional shin guards and properly fabricated 3D printed shin guards are included in the study. Exclusions. Any specimens with manufacturing defects, damage, or incorrect dimensions are excluded to ensure fair and reliable testing. Sample size calculation. This study does not involve human participants. Sample size calculation methods such as Craigie and Morgan or G-Power are not applicable. The number of specimens is determined based on a previous lab study by Kazan Martin and colleagues. For this study, three specimens are tested, consisting of one conventional shin guards and two different 3D printed shin guards. Each specimens undergo 3 impact trials, giving a total of 9 impact tests. Instrumentation. The conventional specimen is the Kipstar F100. The experimental specimens are 3D printed shin guards designed using Autodesk software and Sharper 3D and fabricated using Anycubic Cobra and Bamboo Lab A1 3D printers. Lab testing is conducted using a drop impact test using force plate, which records two important measurements: impact force measured in newtons and energy absorption measured in joules. This is the data collection procedures. Let's continue with data analysis. Descriptive statistic, including the mean and standard deviation, will be used to summarize the impact force and energy absorption values for each shin guard type. To compare the protection performance between conventional and 3D printed shin guards, an independent sample t-test will be performed. The level of statistical significance is set at p less than 0.05. These are the references for the study. That's all from me. Thank you and have a good day.